Do you know which one of these is cement and which one of these is concrete? No? Consider yourself lucky. I'll help you out. A few months ago, I was just like you. I had no idea which one of these was which. But over the last few months, our group has explored exactly what concrete is.
Over this past semester, our team has bonded greatly emotionally. We have learned a lot, not only about concrete, but the application of the engineering design process. With this roller coaster of a project, we spent many nights wondering if we'd even have a functioning product at Fed. But our hours of work and sweat and tears led up to one crucial moment. But first, allow us to introduce ourselves. My name is Yusuf Siddiqui. I'm an industrial engineering major from Burlington, North Carolina.
I'm Michael Erickson, a computer science major from Hampstead, North Carolina.
I'm Theo Malloy. I'm a mechanical engineering major from Chattanooga, Tennessee.
And I'm Stephen Powell, a mechanical engineering major from Manassas, Virginia.
In order to ensure that our canoe was as great as possible, we implemented the engineering design process. Of course, we were asked the question, how do you make a canoe out of concrete? It was fairly difficult to handle, but of course we started with researching. We consulted many different scholarly sources, including a book about the history of concrete. And we learned that concrete is a fairly simple substance. It's composed of three things: cement, sand, and aggregate. Aggregate can be a combination of very different objects, including pebbles, glass beads, as well as a multitude of different substances, all of which are designed to give the resulting concrete a special property. The special property we were aiming for was low density, so we ultimately chose styrofoam balls as our aggregate. These styrofoam balls were special because they were essentially just fancy air. We wanted to increase the air level in our concrete, and the easiest way to do so was with styrofoam balls.
After deciding what our concrete would be made up of, we had to figure out how to actually shape it. This started with a debate on how V-shaped the cross-section of our canoe would be, and after exchanging multiple emails with our project guru, we eventually decided on the shape and were able to create a 3D CAD model of our canoe mold, which we then 3D printed at 5% infill. Despite such a low infill percentage, each of our insert pieces took 13 hours to print, and our outer mold would have taken 26 hours per piece to print. Simply too long.
This brought us to using styrofoam blocks, which we got from the craft center. We glued the blocks together, then we began to start shaving out the inside of our mold with a spoon. This process took a while, and then we began to prepare the inside of the mold with glue and saran wrap, just making sure for once we put inside the cement that we were able to get it out cleanly.
After deciding on the shape of our canoe, we needed to figure out the right ratio of cement, sand, and aggregate. In our research, we found that standard ratios of concrete always had a 1-to-2 ratio for sand to aggregate, and in our initial round of testing, we tested 6 ratios, all with this base ratio in mind. However, some of our samples did not dry correctly, and measuring the densities of other samples showed that our ratios were too dense. And while one ratio, 1:4:8, was less dense, it was far too brittle. We decided to test the previous ratios again, now taking careful note of the amount of water we used. The second round of testing had our winner, our golden boy, 1:2:4 saucy. Saucy denoting the consistency of the wet mixture.
Once our ratio was achieved, we were able to begin mixing. Mixing was a long process that we ultimately did by hand, and we ran into many concerns over the amount of water that we add. We managed to achieve a perfect saucy consistency, which we then poured into our foam mold. Our foam mold, we overfilled a tiny bit, so when we were inserting our inner piece, we recognized that it wasn't exactly flush with the foam. Ultimately, we decided it was close enough and continued on, but then we had to wait.
Once our canoe was dry, then came the process of actually taking it out of the mold. While this should have been simple, we forgot to cover our insert piece in plastic wrap, meaning it was now embedded in the concrete. We ended up having to spend 40 minutes slowly destroying our 3D print that had taken so long to create. If we had to do this project over again, this would definitely be the part that we would do differently.
We had our final product, and we were ready to test it. We put it in the water, and it floated. We were happy, but we had forgotten one thing: our constraints. We had to ensure that our width was 6 inches maximum, but our width was slightly too large. So what did we have to do? We had to scrape it.
Scraping down the concrete not only helped us to get it into the proper dimensions for Fed, but also to get it into the correct concave canoe shape that we wanted. We then decided to paint the outside of the canoe with a cement and water mixture, and we were a little worried about the timing for this as Fed was coming up in the next few days.
We woke up bright and early and rushed to Fed, where it was very interesting to talk to all the other teams for the concrete canoe. After much anticipation, it was finally time to compete. We were shocked by the amount of marbles it held, 2.2 kilograms or nearly 5 pounds. This was so much, in fact, that we ended up placing first out of the 10 teams that were there.
When asking ourselves why we won Fed, we think it was a combination of our attention to detail, our rigorous testing, and our ability to present our product. Well, we really enjoyed this roller coaster of a project. Despite our pitfalls, we felt like we learned a lot about the application design process, and we are really happy with our ultimate success.
Now for the send-off.
That's perfect, actually.
Yo!